Okay, Connor, I just wanted to follow up with some of the first and second derivative ideas here. First of all, on this page, I have a picture at the right of this maybe a negative fourth degree polynomial, and estimates of the slopes of the tangent lines are on, I've written beside the graph, okay? So in this first section, our slopes are positive 5, 2, half, 0, negative a half, or negative 2, negative 3, negative 5. All right? So those slopes are, first of all, the slopes are decreasing. We're going from positive 5 to negative 5. Slopes are decreasing. So our function is concave down. In the second section, the slopes go from negative 5 to positive 3. So the slopes are increasing and the function is concave up. In the third section, the slopes are going from 3 to negative 6, so the slopes are decreasing, and our function is concave down. So here at the left, we have 4 graphs, and we're supposed to decide if the function is increasing at an increasing rate, or increasing at a decreasing rate, or decreasing at an increasing rate, or decreasing at a decreasing rate. So if we just take a look at the first part, which of these graphs are increasing and which of these are decreasing? Well, number 1 is increasing. Number 2 is decreasing. Number 3 is increasing. Number 4 is decreasing. But the question is, at what rate? Or at what, how are those rates behaving? Are the rates increasing or decreasing? So if we look at graph number 1, we could say our rates are going from really small positive, so maybe like positive a fourth, positive a half, positive 1, positive 3. Okay, so our slopes are going from smaller to bigger, so our slopes are increasing. So we would say that our function is increasing at an increasing rate. So this would be A. Okay. So I'm just going to jump over to this next increasing one, number 3. So here our rate might be 5, then 3, then 1, then a half, then a fourth. Okay, so here our slopes are positive all the time. That's why it's increasing. But our slopes are going from 5 down to a fourth. All right, so our slopes are decreasing. So this would be increasing at a decreasing rate. So that would be B. All right, so when we think about these things, increasing means f prime is greater than 0. At an increasing rate means f double prime is also greater than 0. Okay, here, this means f prime is greater than 0. Notice all our slopes are positive, but at a decreasing rate, this means that our second derivative is going to be negative. Okay, graph number 2 is decreasing. Slopes might be negative a fourth, negative a half, negative 1, negative 3, negative 5. Okay, our slopes are all negative. That's the decreasing part. So f prime is less than 0. All right, but our slopes are small and getting bigger negative. So we're really decreasing at a decreasing rate. So negative 1/4 to negative 5, those are decreasing. All right, so that part means f double prime is less than 0. So our graph is concave down. Okay, and so decreasing at a decreasing rate, that is D. Last one is obviously C, but let's check it out. So we know it's decreasing, the function is decreasing. I should never use the word it. I don't know what it is. So let's always refer to things specifically. So I'm talking about f of x is decreasing. F prime is less than 0. So maybe negative 3, negative 2, negative 1, negative a fourth. Okay, negative an eighth. All right, the value of the slopes, negative 3 to negative 1/8, those slopes are increasing. So graph 4 would be decreasing at an increasing rate. So f double prime is positive, our graph is concave up, and this would be C. Okay, hopefully you're wrapping your head around that one. I'd also like to go back to section 2.5 and taking a look at, I don't know if you did this in your notes or not, but we were supposed to match the derivative graph, second derivative graph here at the right with the function graph here at the left. All right, so A through F over here on the right is going to be matched to 1, 2, 3, 4, 5, 6 on the left. Okay, so remember, what does the second derivative tell us about our graph? If f double prime is greater than 0, our graph has to be concave up. And if f double prime is less than 0, our graph has to be concave down. All right, so let's just take a look at graph letter A. All right, it looks like there's a 0 here. Slopes are negative, then positive for my second derivative. All right, so I want to look for concave down and then concave up on my function. Okay, so first graph is concave up, concave down. It also splits at 0. Second graph is concave down and then concave up. I'm thinking that we're probably going to be at that graph. I don't know. Maybe not. It could be, although the 0 is in a little bit different spot. Oh, no, I lied. What am I talking about? Undo that. You're probably thinking I'm crazy, because I am. So this graph was not concave down and concave up. This graph was concave down the whole time. Right? That's concave down the whole time, so don't even listen to me there. All right, so let's keep looking. I need to find concave down. Okay. Looks like we're concave down and then concave up. I kind of like graph 4, right? Concave down, concave up. Okay, let's find the graph that's concave down all the time. Okay, the second derivative, so where the second derivative is negative all the time. Concave down is number 2. And which one of these functions for the second derivative is negative all the time? It looks like graph F. So let's put F over here. Okay, let's see if I can do a better job on the next one. I'm going to go to graph number 1. Graph number 1 is concave up to the left of 0 and concave down to the right of 0. Okay? Is there a graph that does that for the second derivative, positive to the left and negative to the right? Okay, well this one has positive values to the left and negative to the right. This has negative to the left and positive to the right. This one has negatives and positives and negatives. Okay, so I'm going to guess that we have to put B with graph number 1. Okay. I want to take a look at graph number 5. I think I like this one. So it looks like our graph is concave down to a certain point, maybe, at 1. Then it's concave up, maybe to 3. And then it's concave down. So it's down, up, down. It's a dud. All right, so that means my second derivative must be negative, then positive, then negative. So let's look for that. All right, D's out. Let's look at E. At 1, the graph is changing from negative to positive. So F double prime went from negative to positive, and back at 3, it went back down to negative. Well, that seems to follow the pattern. Negative second derivative, positive, negative. I think 5 is E. Okie dokie. Let's look at graph number 6. We know we're concave down to the left, and we know we're concave up to the right. So we have to have a negative second derivative, then a positive second derivative. Right? And graph C is doing way too much stuff, so D must go with 6. All right, so obviously 3 and C go together, but let's check it out. Does it look like there might be a point of inflection, a point of inflection, a point of inflection, where we change from concave down to up to down to up? All right, so that means we must go from negative to positive to negative to positive for my second derivative. Let's check it out. Negative, positive, negative, positive. All right, so graph C goes with number 3. All right, last page. I'm going to see if I can do this in 3 minutes. Okay, generally when you're given some information about a graph and you need to graph the function, look at the pieces that you're given. So in the first section of information, you're given actual points on the graph. So you can plot those. The second bit of information, you're given something you know about the first derivative. So this is going to relate to increasing or decreasing ideas on F. The third part relates to the second derivative. So this is going to be talking about concave up or concave down sections of your graph. So you need to decide what's happening in each section. So let's first graph the points. Negative 1 is at 4. That's that one. 0, 2. 2, 1. And 3, 0. Okay. All right, so we have those points on our graph. Now I'm going to look, and it says there's a dividing line at x equals 3. So I'm just going to put this on here. That's a dividing line for where my function is going to be, if my derivative is negative, my function must be decreasing for x less than 3. So decreasing, all in here. F is decreasing. Here, F is increasing. Okay, so we've got that going on. So I know I have to go from this point down to this point, down to this point, down to this point, but then after that I have to come up. All right, so I've just noted what's happening there. Okay, what's happening with the second derivative? Remember, when the second derivative is negative, your graph must be concave down. Okay, so on 0 to 2, so between 0 and 2, my graph is concave down. Everywhere else, it's got to be concave up. So here to the left, it's concave up, and here to the right, it's concave up. Okay, so we're going to try to put our graph together. In the first section, between negative 1 and 0, we're concave up and decreasing. So concave up and decreasing. In the second section, we are still decreasing, but we're concave down. Okay, so this point is a point of inflection. All right, I'm going to look between 2 and 3. I'm still decreasing, but concave up. Again, this is a point of inflection. And now at 3, we have to change from decreasing to increasing, still concave up. Okay? So there's a picture of the f of x graph, and you did